work on the design of a fixed wing UAV, and then design of multi-rotors UAV. Okay, so people are starting with this basics, and then they start with the fabrications of the aircrafts. Okay, so your batch also started with the direct fabrication, not like designing. I think there was too much delay, so they started directly fabricating using
Yes, sir. Puneet said.
existing model. Yeah, yeah, Srikant.
Yes, sir. Puneet said that, sir, about the design. He didn't get.
Just I will share that. I think already have gone through this, correct? All types of this, and you can pick up one or two. I will show you. When we started this the tutorial side, I think one tutorial I have started already. I will show you again in this. Then I will show you few hardwares.
Yes, sir.
I will be live with the video to show you the hardwares. Time being, just I'm projecting the PPT so you can go through them. Yeah, so actually, just I think I shared this one course plan, correct? So this was the course plan related to the avionics system engineering, and under the avionics system engineering is supposed to be applying the system engineering in the development of their aircrafts. Okay, and maybe the system integrations, or maybe coming with the final products for deployment. So the whole idea was there, because you have a systems related to the drones, so you can start with the small drone development using like a fixed wing aircraft or VTOLs or maybe the multi-rotors, and then you're integrating the all the instruments, and then at the end you are testing on the ground, okay, in the lab, and then finally you are going to deploy the like your aircrafts in the actual environment, or maybe real flight. Okay, so flight testing, and then you are analyzing further. Okay, so this is like a main motto behind this system engineering. And maybe there was like a what type of communication systems. So learning deep is the other idea, because every equipment, if you touch, you can go with the very deep designs, or maybe exploring more about that, what is the technicals, okay, in terms of the design development, or maybe further research. So there is lots of hardware. I think maybe you have visited in the lab or not, I'm not remember now, but if you visited the center, then I think you've seen the lots of hardware available, and most of the your batch also has gone through those hardwares. Okay, they started at this basics. So if you check the first experiment, or you can tell like one of the area we're supposed to start is actually learning how to design a system. Okay, going with the preliminary designs, like going with the, you have requirements, then conceptual designs, then preliminary designs, then coming with the detailed design, final product, okay, and then deployment. Okay. So that's the main motto of first experiment, which will be continuing till 1 week or 2 week itself, like 2 or 3 experiments. So if you know the CAD models, or maybe if you know the FEM CFD, you can pick up one of the plant and then you can start working on that, and let's submit something as a lab reports related to the design part. Okay. So once you have like a software design part, then mostly we tell a student can work on the
Sir,
feature.
sir, sorry to disturb you. I think your video, I think, is playing.
Which video?
MATLAB video, sir.
Just, is it not visible? Huh? Just 1 minute.
Yes, sir. Now it's clear.
What are you able to see now?
Curriculum, sir. Regarding the lab.
Right?
Yes.
I will join in the system also because I have to show you the this hardware. Yeah, so first experiment was if you have software part, then you can go with the manufacturing. Okay, so manufacturing in terms of the, either you're going with the soft materials or maybe hard materials, or maybe composite fabrication itself. So if you're going with the soft materials, then mostly we are talking about the balsa ply, balsa wood, I mean veneers, okay, carbon tubes, those things, correct? And assembling those parts based on your designs. So you require like a 2D, like a cutting machine. Maybe you can tell like a laser cutting machine. So you have laser engraver where you can go with the cutting the 2D designs, and you can assemble with the some paste. Okay, mostly we use the araldite and epoxy resin for pasting that type of, or maybe you have flex quick for that. Okay, so very quick type of materials also used for that. So this is the first prototyping where you can use the skeleton in terms of the balsa ply, in terms of the veneer, or in terms of the maybe carbon tubes, and then you have monocoat over that. Okay, so you can have some coating as a skin, and that skin can have uh, what is called monocoat materials. Okay, so if you check that, then you will get those type of materials available in the lab, in the market also. You can check what is that materials. Okay, and the next part, people are using the what is called foam materials, correct? So you have different type of, is it going with the XPS foam or normal what you have seen the foam materials, or maybe you have PU foams. So different type of materials, so they use for cutting the particular shape as per the 3D design, and then just putting some materials over that. It can be a glass fiber one coat or something like that, or just you have to insert some hard materials, either carbon tubes or maybe some skeleton. Okay, so then this is another type of like designs. And third designs, you can go with the composite related. So if you want to design the composite, means you need the mold, correct? Mold is a very important part, means you need a skeleton. A skeleton actually is not, I'm talking about the wire frame, but I'm talking about the shape of the system. Okay, so you should have a skin type of, and that skin top, but bottom you will see like any materials which makes hard of that. Okay, so like that is the mold. Mold can be used as a PU form. You have to machine using the CNC machine, like a 3D machining of that. So there will be CNC engraver machine which will machine the parts as per your 3D designs. Okay, so you should have multiple parts, okay, based on your fuselage parts, beings. Then you have control surfaces, maybe horizontal stabilizer, vertical stabilizer, rudder, some control surfaces, elevators, then maybe ailerons. So small parts what is required, that you have to mold to. First you have to machine that, and then you should use that machined part for the fabricating the mold. Okay, so mold will give you the some shape. And if you use the composite materials like fibers, it can be a glass fiber, can be a composite in terms of your carbon fiber, or sometimes hard materials we use the metal matrix composite. Okay, if you're looking like a hard material, not only just a skin but a skeleton, then you can use that type of material.
PLM, sir.
No, there will be like I think you have seen most of the roof side, or maybe every buildings they are using for the what is called that finishing part. I think aluminum you have seen that, correct? Both side aluminum,
Yes,
thin layer will be there, and middle there will be some soft materials. That is the metal matrix composite. Okay, so people are using that also. And everywhere you have seen, I think they are coming with the different colors. So people use for building constructions to just showcase. Okay, outer sections where mostly they place the glasses, those things. So normally once you have a mold, then actually we are making the skins. So you need a vacuum bagging process, and once you have a composite skins with that particular shape, then you are going to integrate that first, like making shape. If you have two parts, then how going to be combined those parts using some epoxy resin or hardener type of materials. So that you requires some paste, and then you have to fixed. Okay, it can be within 24 hours or maybe 5 minutes. It depends on the what type of materials you have, rate you have. 5 minutes or maybe the 24 hours related. Okay, so within 24 hours your parts will be ready after attachment. Okay, then you need the further process like cutting that. I think if a video is there, then in the future I will show you what the process are there. And then I will show you a few like models. And then lots of, I think, hardware you are going to get exposure. Okay, so basics hardware I will show you, and one or two at least I will show you how is working that. At least basics, so you will get exposure to explore that. Okay, so this is the idea. And then next, when it starts, if you have a physical models without the electronics, then we start what type of electronics should be integrated with that, because those things already you design under the detailed design. So you know that what type of propulsion system should be there. Is it electric or maybe the fuel based? Okay, so I will show you two propulsion system also. And then there will be like autopilot systems. So there are multiple autopilot. I will show you one here. And then what are the physical connections required for autopilot system? Then communication system means telemetry to communicate from your ground control station to the UAV autopilot system. And maybe you have camera related communications to transmit videos. So you have another video TX-RX. Okay, so I will take you all those basics hardware, so you will get exposure. Okay, so that's the idea. And these all I think if you check this combined, this is not like the single day task, means you can go with the all. Okay, but first getting the little bit idea what are these things. Okay, and maybe next class I will be showing the all this camera TX-RX related, and then you can see the RVT design, how mostly you will get the video, okay, from one location to another. Then mission planner, those things will give you. So there is an idea like you can go with the at least ground setup first, all this hardware in loop simulator, without connecting with the your what is called aircrafts. Okay, so first you should test on the ground. So we called actually hardware loop simulator design to test ground setup of all your instruments. Okay, so this is actually further exploring. First starting will be like exploring the hardwares, and further you are going to integrate that is the main motto here. And actually if you are looking like, let's say, have sensor fusion, those things, or maybe basics, what are the inner sensors are there which will give you basic information about the aircraft, then you can go with this also. Okay, and these are the advanced which is not possible now. When you are here sometimes in the future, then you can get exposure. Okay, we have one or two board is also there, and but this all your electronics here is also working there based on the I2C SPI communications. If you have camera with the network LAN, you're going to use then network, maybe that also going to use. Okay, so depends what type of communication protocols and available to communicate in this case. Okay, so MAV protocols is available in the aircraft side, UAV related, so you can explore that also. Okay, then I will show you at least what the camera related, then computer vision one code I will share. You can just try to track that. Okay, so code I will share, maybe you can just check what is the code has written in the MATLAB, then you can explore. Okay, and I will show you two systems, one maybe the multi-rotors related, and I will show you what are the equipments or instruments integrated with that. Okay, flying is not possible. At least I will show you the what are the systems or maybe components are integrated and what are the function of that. Okay, then I will take you basics integrations. Okay, what are the equipments integrated. So on the ground I'm going to show you that. Okay, so this is the same thing, and one of the models like composite fixed wing aircraft, I can take you, I think this is the mistake is there. Okay, so composite related, what are the materials, those things I can show you. I will take a videos of that. I'll say what are the components are there, what are the materials required, those are things, or maybe photo I will show you what are those things. Okay, so we'll get the exposure. Maybe you can check with the design and development process of composites. Okay, I think your batchmates also got the exposure. They work I think maybe 1 month for designing one model. So that is basic you're learning till camera integrations. Okay, and I think you have seen in the lab one antenna tracker also. So those systems are integrated. So maybe you are learning basics at least online. Physically, if you're here, then you can go get the exposure. What of those things are there? Okay, lots of systems are there. So I will take you first one model. I think previous class we started with this, correct? During the airborne platform system design, and then I told you when you go the all, I'm not going completely, but I will go fast, correct? You have already gone through this. So idea is there, if you want to develop any systems, okay, like this under the avionics system engineering, so you should have basics knowledge about the system engineering, starting with the customer requirement and then till the deployment, correct, validation and verifications. Once you hand over to the customer, then your projects ended. Okay, means that closure comes in the picture. Just after that you have maintenance, all those things. Okay, so this is the idea, like these 4 points suggest. So you should have one systems with the payloads. Okay, what type payloads is it? The synthetic aperture radars or a basics camera, but you should have a one platform learning under the engineering, avionics system engineering, because the whole avionics systems depends on your platform, correct? Is it your normal UAV or maybe bigger UAV like actual drones, or maybe aircrafts, military aircrafts, spacecrafts, or maybe the satellites? So actually you need one type of platform, and then only you can talk about the avionics systems. Okay, then further what is the development requirement is there. Then you require how to control whole system here, correct? So if you bigger aircraft, actual passenger aircraft, you have ATC, correct? ATC type of systems, radar related. But here, when we talk about the UAV, without the persons on board, because this is the unmanned aircraft systems, correct? So actually no one is on the systems. So of course, whole control of this aircraft is actually controlled by the ground stations people. Okay. In some staffs or pilots or maybe observers are sitting on the ground in the ground stations. Okay, this is very huge. I will tell you at least cost analysis. This cost already I think I told 80% or 90% cost goes as actual aircrafts. Okay, so this is not like a very small thing if you are talking about the bigger aircrafts, unmanned aircraft systems. And this GCS is also very huge. Okay, this cost again very high, 40 to 50% of that. So this is again very costly because you should have very bigger communication system related. Okay, so when you talk about first platform, okay, with the payloads, okay, cameras, those things, you have the radar, something. Yes, satcom is actually this is the satcom time being on this. And then you have a ground controller stations. Huge ground controller stations require either you are going to control the whole aircraft or going to control the mission of the aircraft, like what are the camera or payload integrated with that. Those data analysis, if you want, then some observer will be there to use that. Okay, so that's the idea here. And then third point of this, when we talk about the avionics system engineering, means comes the communications. These two systems cannot communicate physically, correct? If on the ground, then fine, that is fine, you can go ahead with that. But actually communication never happens with the physical connections with the aircrafts and this ground controller stations. Okay, maybe person sitting inside, then fine, it is physically attached with the system. But when people is not here, yeah, is not there, then of course you're connecting through the some wireless communications, yeah, satellite communications, yeah, RF communications. Okay, so of course you're talking about the wireless communication. There is no physical connections, there is no wire. Okay, so you need a huge connections. It can be a RF communications. Okay, it can be a satellite communications. So if you're going with the like 200 kilometer or 300 kilometer flight range, then you can go with the RF communications. Okay, using the very large what is called antenna. This can be around 12 feet or 15 feet or 20 feet type of this disk area. Okay, so very large this, and then this can go with the like a communications around 300 kilometer or 400 kilometer range. But when you're flying for 1000 kilometers, means you should have little bit different communications. Means this cannot work for line of sight, correct? You should go beyond of line of sight. In that case, means maybe this type of communication is not working. Okay, so this will be directly launching to the satellite side, means they should give to the satcom, and satcom will control the aircraft, and anything's coming from the aircraft that will be transmitted to the satcom, like a satellite communication system, and then satellite communication system transmitting back to this communications, and this communication system physically will be attached with the GCS, so observing there. Okay, so I think this is the whole mission of your system engineering. Either going with the very large aircraft or going with the smaller aircraft, idea is the same, design is the same, only complexity will be less. Okay, cost will be less, and maybe you are going to compromise with the protocols or standards which require for this. But when you're going with the military standards, actually people are talking the similar approach. Okay, is it going for the smaller or bigger, never does not matter, but you should have military standard all the components. Okay, so every protocols or test protocols or maybe design protocols, material protocols, all will be under the military standards. Okay, so you go with the anything, but you should have followed that. Okay, so this was just part of that. I think you should starting with the wing. Wing is the part of the aircrafts, and then you have fuselage parts. Okay, this is what is coming. This part is the fuselage. This is also fuselage parts only. Then you have a camera, payload, landing gears will be there. Then you have at least control surfaces related, horizontal or vertical stabilizer. This is a V shape, so you have different control surfaces deflection in this, but normal either T or maybe opposite T is something, inverted T will be there. So depends. This is a tail boom because this comes middle of that. Otherwise, if your motor is this at the nearby the notch, then I think you have a single only tail part here, not tail boom like this. Okay, so depends how your aircraft designed. Based on that, you have to look at the different configurations. Okay, so of course I think you have gone through this various type of aircrafts is there, and I'm not going too much about that, but I'm going fast to this, so you will get more exposure now. Okay, so you have to pick up at least one designs, and then you're working submitting for 2 labs, one related to the fixed wing and another related to the multi rotors. You can go with the quad or maybe hexa. Okay, or you can go with the detachment of the one aircraft from the another aircrafts, taking like a one fixed wing aircraft and let's your multi rotors should be detached from there without disturbing the first aircrafts. Okay, so that way you can go with the designing one at least, which includes your fixed wing as well as the multi rotors. Multi rotors can be detached in the future if required from particular height, and fixed winglets going to be fly. Okay, so that much mass margin should be there. If particular aircraft reduces particular mass during the detachment of that, then of course that should not affect the stability. Okay, so you can decide designing one system with the detachment of the multi rotors and main platform is actually fixed wing, that you can do, or going with the different models then attaching that. Okay, so this is the idea. I think you have various types of starting with the very micro level. Yeah, nano now, nano to nano we cannot tell in terms of the what is the 10 to the power minus 9 getting correct. The nano means very small. You're going with the maybe 5 gram 10 gram type of insects or maybe something like that. So going very small modules sub insect type of that coming under that. Okay, so depends what is the size of the aircraft or what is the endurance you are talking. Okay, based on that your design, your system engineering going to be changed. Okay, so this is the different, and I think already I told people are now they're doing the what's called cyborg. Okay, means how to control the real life insects or maybe bird or maybe the human itself, like robotic systems. So if you're doing like that, then how to get controlled, because you cannot directly control this. You should have a systems integrated with this to control the brain or maybe movement at least of this signals, how to capture or maybe disturbing the word signals, and then you're controlling from the ground stations. Okay, so you should have a design, and every design is going to change the your avionics designs. Okay, or maybe softwares or maybe your requirements. So applications depends on the applications also, your systems avionics system going to be changed. Okay, so let's pass this fast. I think I want to show you. So following one of the design which cover the all your designs, then you have controls, then guidance, navigations, like complete GNC systems. Okay, like a whole operations. Then you will get the multiple phases, and you should follow this type of system engineering, then breaking down the requirements for each phase, and then developing that. Correct. So I think you can work one of the any models. Maybe I think you can work on this or this or maybe this or this, like that, anything. Okay, and let's see you design first. Okay, so previous class, during the class also I have highlighted one of the model. I'm not going theory now, I will show you. So we start always with the conceptual design with the some requirements. Is it what the customer needs, what is the predicted size of the market? This is like a conceptual suggest based on your market analysis if you're talking about the product development. Okay, then you should have cost analysis. What is the operating cost once you going, that will be acceptable by the customers. Okay, any other external stops, any sales related or any non-recurring cost of the programs, that also should be there. And what the agency coming in the picture when you're going to deploy that, or maybe coming with the markets. Okay, so you should have a clear picture of the requirements, technical, non-technical, all those. Okay, looking like a thinking like product development. So starting the conceptual designs, then you should have little more details where you're coming with the softwares or maybe basics, rough models designed with any materials, wood or maybe some clay type of materials, like a simple, which is not actually required, just giving some shape to get that. Okay, what are the complexities there, how you get to look and feel, and what are the problems will arise when you are going to manufacture. Okay, so preliminary designs comes with the minimum cost analysis and coming with at least one of the physical models. Okay, and then you are going with the details design for the coming with the actual prototyping model, which will be testing for the customer requirement. Okay, so that you can go through that, you have this already. So you start with the design requirement, sizing, what their files you have to select for the particular aircrafts. Okay, then what their performance, you can go with the mathematical models, those things, then fabrications, testing. Okay, so this is basics. You should have at least some designs requirement, you should have some speed, what the speed maximum can reach, or what the minimum speed you're talking, because minimum speed will tell you what the minimum lift you can generate, half rho v square s into cl. Okay, so if v is the minimum, then you should check what is the minimum lift you can generate. Okay, you cannot, if you are going below of this, maybe your lift is not sufficient to take off your aircrafts. Okay, so you should check what is the minimum speed of the aircraft should be there, which can give you the enough what is called enough lift to take your aircraft in the air. Okay, so that you have to remember. I think just to change this. Okay, what the maximum you are talking about, because every aircraft cannot go very high speed because the structural or maybe design constraints or maybe very lightweight systems. So depends on what, then propulsion systems, so depends what type of propulsion system are there and what the maximum speed you can achieve. So maximum speed means what are the maximum payload you are talking about, that correct? Because at
Yes,
the
sir.
max, yeah. Okay, so this is thinking like you have 6.5 kg type of maximum takeoff design, and going with the particular chord variation. You know the chord? Remember the chord or not?
Yes, sir. Yes, sir.
Yeah, so if you cut this vertical section, then you will get the shape. So either you have symmetric airfoils. Chord means what the airfoil comes after cutting the beam, vertical cut. Then you will get the trailing, leading to trailing edge. What is the length that is there? But if you check if camber, then I think chord comes the straight line. Camber will be little bit curve. Okay, so you have camber. What is the thickness is there? That is the perpendicular thickness between the perpendicular distance between the cambered and the chord line. Okay, so these are the standard points you have to pick up, the what is the airfoil should be there. Okay, and what is the chord length you are talking about, that what the wing span you are talking about. So what will be the wing span area. Okay, so based on wing span area, based on your velocity, how much you can achieve the lift. Okay, and when you are achieving the lift, so what are the variation of angle of attack? Maybe at particular angle, this is going to be a stall. Okay, so after that, maybe lift coefficient loss will be there, means lift going to be decreased. Okay, so you should know that every angle of every files has a limitations. So you should select based on that. Maybe not or some series you can pick up that. Okay, and then you should find what the stall angle is, should be working below of that. Okay, then wing area is this, and then you're analyzing. Okay, Reynolds number versus velocity, depends which aircrafts coming under what is the Reynolds number. So those things you can analyze. So then you're finding the all data related to the particular files characteristics. Okay, so these are like a idea, means people are going with the different airfoils and they do the all analysis, all 6 coefficient analysis with the angle of attack or maybe side slip. Okay, so they will analyze the variations of all those. okay, and what is the maximum CL you are achieving, what is the maximum CD you are achieving, because maximum CD is not good. You should have very minimum, very small, so it's fine. But when stalling this, then you will see you should not follow that particular angle of attack. Okay. So what we was talking about this, if clock Y, then you should have, you have to plot that. Let's you get first this step. And if you're talking about the variable airfoils in the wing, then maybe at the fuselage point where you're actually attaching your wing, that should be larger chord length. Okay, and when you're going tip side, okay, then maybe you have a smaller chord length. Okay, so that is like a taper type of wing you can check. Sometimes people are designing that also, but you should have good design, so this will sustain in the air when engine cutoff is there. Okay, so that is there. I think basically should go, you can explore more, then you design that, find out what is the maximum CL you can achieve. Okay, this is the what is the basics selected. Then materials, use the fiber to design that, glass fiber. We can go with any type of materials. Then what are the thrust variations with respect to speed? If you're talking about this range, this region, then what you will see power, this at this particular speed, I think this power available is this, correct? Thrust required versus speed. And if you're going at the higher speed, maybe again increasing. But is it there is a limitations or not? That also you have to check. If there is a limitations, you have to go with that only. Maybe within you can check till 10. You are looking like a thrust requirement is high. Okay, and maybe this is not enough for lift generation also. So of course you have to remove this part. Okay, and maybe after 15 to 20 may not be good, that also possible. Okay, so if you're looking like a basic thrust requirement for propelling the aircraft, then this part is good. Okay, this part, of course this part is good, but when you're thinking like what is the thrust, maybe if very large for this particular speed, so you should justify, is it your need of the speed should be this much for generating that much lift or not? Okay, because only V is coming as a Vs square in the left side, since L is the directly proportional to V square, correct? So only CL variations, if you're going more than one or maybe coming nearby one, then this only will affect your V speed. Okay, so we cannot go with the very high speed also, because your thrust requirement will be high, means unnecessarily you are taking too much load on the propulsion system side. Okay, so these are analysis, means you should have a minimum thrust requirement, your power requirement from the engine side at a particular speed. Okay, so did there, means people should analyze all those, then CL versus CD, then other if rate of climb versus speeds, because you are going fast, correct? What the rate of climb, then that also you have to analyze. Okay, so these are some formula I shared, correct, long back. I shared this, so you can use this, and then you try to figure out one aircraft. And maybe the second semester also you have come up with the one design, just to check that and make little professional design to submit in the lab. Okay, so I think this is there where you're finding all the coefficients, and in the lab also I told how to find the coefficients. If you have experimental data, then you can take the delts, like what is the change in the CL versus change in the angle of attack. That way you can do that. And if you're talking about the maybe experimental data is not there, then you have to work with the first principle method. Means you should know the parameter or maybe equations of a particular functions, or maybe parameter like a CL, what is the function with respect to the V, with respect to the CL, or maybe with respect to the other parameters. Okay, so you're using that as a first principle method and then deriving the equations for coefficient. Okay, so Jacobian, mostly Jacobian we are going to use for that also sometimes to find this. Okay, so how this are finding, that is the main idea, means you are finding this constants coefficient. This is like a CM naught alpha. Okay, so if you know the alpha variation, if you know the CM naught variation, then only you can do. Otherwise, what are the CM naught equations? And what is the function of alpha? If you do the partial derivative of that, then you will get the your equations. Okay, so that way we are actually finding that every parameter we supposed to find that, then find what is the pitching moment coefficient at zero angle of attack. This alpha m naught means zero angle of attack. Then propulsion system. So I will show you. I think this is the either you check the OS engine, DL engine, maybe Rotex engine. Many engines are coming. You can check with that. Multiple engines are available in the market. Okay, where mostly comes with the what is the CC. Okay, and what the normally I think one just I brought very small engines here. I think this is the not sure which company is this, but OS engine. Yes, I will show you that. I think I will show you once you finish this. Then I will show you what the engine is there. Okay, so we are talking about the weight of the engine. Weight of the engine will be very high in terms of the motor, but when you check compare with the battery, battery weight will be very high in comparison to the engines. Okay, so you should justify what is the your need. Is it your need is actually where is that? Need is the long endurance where you can get a support from the engine only, or maybe you have electric motor where your support will get from the battery only. Okay, so you should justify because engines weight will be very high in comparison to the motor, and if you compare the battery, then battery weight will be very high in comparison to the fuel. Okay, but I think if you compare, then if you have that much fuel in comparison to the battery, then endurance will be in terms of hours, 2 hours, 3 hours, like that. Okay, but same weight constant will give you 30 minutes, 40 minutes maximum in the electric motor. So of course, the electric side you have less vibrations, and engine side have more vibrations. And once you have like once run, you cannot off in the air. Okay, in the engine side, if you're not electric starter. Okay, and sometimes you have to start from the ground, and then let's your aircraft should get back on the ground again. Then you stop the engines. Okay, so engine cut is not recommended in the air, but electric motor you can cut down the what is called power in the air, means you can stop the your motor in the air. Okay, so let's looks like a glider. Okay, that can glide for some times. Okay, without power on. So that type of flexibility is there. Okay, so I'm not explaining too much about the engines, but I will show you one engine. Okay, I think you can see that. Let's I will show you. So first I will show you two type of propulsion system. How I will connect this. Let's see this join. I don't know how to come up with this. Yeah, I think just I've taken one engine. You can check this. I don't have propeller now, but mostly propeller is going to attach here. You see this one engine. Able to see this, Srikant? I should share, huh?
No, sir. It's showing the course plan.
Okay, just I think I will share from here. Share video. That's now getting.
Not yet, sir.
Yeah. So this was one engines. Mostly this is very small. I think this was the 5cc around 10cc or 15cc. We have a very large.
Sir, the screen is stuck, I think, sir.
Yeah.
It's not showing, sir. It's stuck.
If you check this, this is actually what we are setting up. Normally, you know this very well.
Sir, it's showing MTech event first semester folder.
Is it not able to see? Huh?
Yes, sir.
Okay. What is this? 1 minute. Now?
No, sir.
Just check once. So this is a presenting now.
It's showing, I think, sir. I think it's not showing.
Okay, just I will show you maybe. So this will be tough from this. Very tough. So you can see this, huh? Able to see this? Are you getting? Yeah. Voice is not coming. Okay, so you know this?
Yes,
what is
sir.
that? Spark plug.
Yes, sir. Fins and spark plug.
Yeah. So for bigger engine, you have like this, and normally what is called this is your shaft. So mostly you are connecting the propeller. Okay. And if you have this actual, mostly we use the servo. Servo is already kept here. I think I will show you this servo is there. Okay. So one servo just I placed. I will show you this one. Okay, so very small servo we use to control this engines. Okay, so if you have this shaft connected with this, so what you will see, I think you can't see here. You're opening the valve, correct? And this
Yes,
valve
yes.
will open the air. Okay, and fuel is already going through this. Okay, so one fuel you have to connect through this. So we are actually passing the fuel also. If you check here, so fuel and air will get mixed, and then all your engine performance, how you know that you can perform. So if you see the proper way, we are attaching like this. Okay, we are attaching something like this. So you have like front side. If you are talking about the back, you have seen in the aircraft, correct? One,
Yes,
which
sir.
one? Pusher side. So actually you are talking like this. Yeah? Okay, your fuselage back side will be connected here. So you need a stand, proper stand here. This is the stand. So they give the proper mount. Okay, and they will be fixing like this. So this is one of the very small engine we got in the lab. I think this is very smallest in our side. How bigger you are able to see? You see, I don't have this much. Just I think this much. Just this much. Very small. It is not very big. This much. Just see. 3 inch, 4 inch. You can tell maximum that size is there, and this can take at least 3 kg, 4 kg aircrafts. Okay, we only just need maximum what is called 60% or 70% your weight of the aircraft, 70% if they are. Okay, so people did not get the enough time to design. I thought like they can work for the smaller aircrafts. Okay, once you have this, then you can go with it. Okay, so mostly this is what is that?
Sir?
What is this?
Exact.
This is exhaust. What is called that? Your smoke will come from this.
Yes, sir. Exhaust.
Yeah, so that there. They have one bigger also, that I think 25cc type of engines, which can take around 10 kg, more than 10 kg type of aircrafts. Okay, so this is the one. I think you should remember the engine related, or you can explore the OS related. This OS engine. Okay, so this is the OS engine. You can see OS engine there. OS has written, and DLE OS you can go with the multiple. Now people are coming with the onboard generators. Okay, so you have like this is the shaft, correct? And this shaft get connected with the engines generator. Okay, so generator also going to be operate based on the rotation of this. Okay, so how it is rotating, based on that also going to be rotating. Very tough sometimes to work on this, because starting this is tougher than the your electric motor. Okay, so you have to work on this first, and then once you have like a engine drive generator, means if generator is also there, then you can power the batteries. Okay, so that there This is one I think you should remember. You can write some details about OS max number. I don't know what is this, but LF15 OS LF15 Japan made. You can go with the some submission of this also basics. Okay, if you want, then I can share you the photo, or otherwise how I can. So I will share. Okay, don't worry.
Japan version, sir.
Huh?
Japan version, sir.
This is Japan. Yeah, made by Japan. OS LA15. I think 5cc something was there. 2.5 or 5cc is not mentioned, but just to go through the details about this. I will share you the one diagram so you can attach in the your this one report. Okay, this is one type of propulsion system. You got that correct? So any aircraft you're designing means you should have either engine driven type of propulsion system, fuel related, but that fuel either going to just use for the thrust generation, or maybe that engine fuel based going to use for both thrust as well as the power generation. So if you use for power generation also means you need a generator. So engine driven generator, that is called IDG sometimes, integrated drive generator. And for integrated drive generator, what we need, because your RPM variations require based on the aircraft need, correct? So what is the main target there? Means you should have sorry, I think I forgot what I want to tell you. Yeah, constant speed. Okay, so if RPM varying based on the your power requirement, your thrust requirement, but the generator always suggests you should have a constant speed. Okay, only then can generate that particular frequency. Your your supply, your voltage supply will be generated the particular frequency. So you need a constant speed. So that CSD is coming, constant speed drive generator will be there. So CSD coming in the picture before the generator, and that will take you what is the maximum frequency can be generated. Okay, so that is the power generations theory is there, where is IDG coming in the picture. Okay, so this is one, you remember this. Now second type I will show you. I think one, what is this? I've seen this. I have now only one type because in the lab I cannot open the video.
Motor.
Okay. So you have brushless DC motor. Mostly what happen, you have three connectors, electric connect. Just see, three wires. This is like a supply to the motors. Okay. To supply this, we need some electronic speed control for this. Sometimes what happen, actually this rotating complete auto runner. Just see, actually complete motor is running.
Yes, sir.
Okay. Only you have to fix this. See, wire you have to fix, correct?
To constant control the torque.
So your auto runner, like you are running this one, but the other design what will be there, this will be fixed. Only your shaft will be running. Okay, so you should check what is the types of the motor you're going to use, and based on that, you mostly when you design the aircraft, then you have to check what is the installation should be there. Okay, so that is the main target. And when you are designing this type of propulsion system, just I think I kept some, yeah, need one speed control like this. Okay, so what is there means you should supply the powers, and you have again three connectors wire. Initial there was like one VCC, one ground, one signal. Okay, now they made such a way that you can connect any wires. So there is no today like you can go with the supply this wire. So previous time there was coming with the color coding in the speed controllers.
Yes, sir. Red and black.
Yeah. Now they removed because lots of mistakes happened, and now they are not using that type of. Only you have to check. Okay, if two connected, if your rotation reverse, then just you change the two wires. Okay, then you will get like actual rotations, which direction you want to generate the thrust. Okay, so depends the current polarity. You can go with the your rotation of the motors. Okay. And what are the other, I think, details specifications I will tell you in the future. Just I have to take you more details about this. So if you see the reading, just I have taken one of the ESC. and a few ESC has very advanced. This other one cost around 16-17,000. Just what I'm showing, this cost around 25,000 around. Okay, so you will see a different speed controller for this. This is the like a 5,000, 6,000 like that. Okay, so what is the important in this? I will tell you. This has yeah.
Sir, speed control is around 5 to 6,000, sir.
No, this for this you should get around 16,000 rupees. 16. Okay, you can go with the higher also. Depends what is the capability of your motor is there. Okay, propulsion system you're talking. We are talking what are the professional all. So this will work till 5 years, 6 years like that. Okay, so if you check with other any ESC, the damaging will be more. That will be like a very fast in comparison to the others. Okay, so we have seen the more failure cases for cheaper ESC. Okay, so what is there in this case? You have 2 to 6 cell they have mentioned. Okay, so is this type of speed controller if you are taking, then you should check what is the rating of your motor. What is the voltage required for this? What is the maximum voltage required? What is the current required? So depends on the thrust requirement. This has a variations of the voltage and current. Okay, and based on that, you need the propeller also. What are the I think no, I will say some other time the propeller, or maybe you have seen that. Okay, so this is the 2 to 6 cell means maximum you can go with the how much? One cell corresponding 3.7 volt. Okay, so what the maximum voltage will be there? Can you multiply 3.7 into 6? 22 point something to 22.2 maybe is coming. You check that.
2.2, sir.
Yeah. So this has a maximum voltage according to the your number of cell requirement. Okay, and there is a minimum voltage also. We cannot go below of that. That is the idea. So this suggests you should not go below of 6 cell, 4 cell. You can go with the more than 4 cell, 6 cell. Higher the voltage will be fine. Okay, that will be fine till limitations. Okay, and then another point in this there is called of BEC 5 volt. They have given the 5 volt at the rate 5 ampere. So this act as a voltage source or current source again. One is a direct supply. What is the battery connected here? That will be given directly connected to the your motor. What is the motor is there? So that direct power supply will be transferred to the motor. Okay, and if you control the your motor through the flight controller, then I think signal PWM signal is coming through this. Okay, but what is there?
So that means we can connect to the battery, or we can connect to the motor also.
No, directly we cannot connect the motor directly with the battery because we have to control this motor. So you need a speed controller. Okay, a speed controller only can connect with the battery, but we are not connecting directly with the battery. I will tell you. I have here some connections. There is called power models. If you check this, there is called power models. Okay, so this power model come to just protect your speed controller also. Sometimes there will be like a damaging your speed controller also be observed during the testing those things. Okay, so when you connect directly battery with the speed controller, okay, there is a chance this will damage because at the end this there will be a Zener diode something inside. Okay, so that mostly get heated and will damage. So for this you should have power model. If anything's happen, there will be melting here. Okay, this is the soldering part. I don't know is it able to see or not, but this is direct connections. This also has a one diode. Okay, anything's happened here, this will get burn. Okay, so actually protecting here. But if in the air this failed means whole aircraft will fall down. Okay, so that the one constant is there. If you don't have power backup, then if power model itself got damaged, your ESC is good, your motor is good, but your power model melt because of the temperature, then I think we are losing the whole aircrafts. Okay, so in that case means you should have very good quality of this, which can like hold at particular time or maybe particular voltage also, because voltage already is specified, but temperature also important. Sometimes if you're getting too much heat, then how this heat creating problem to melt the soldering materials. Okay, so that is one thing. And other point in this, they mention you have 5 volt 5 ampere. So this, when you connect with your flight controller, like you have, I just kept one flight controller here, you see this. So flight controller side, where you are getting output. Okay, so output side, when you are taking output, you have to connect this. Okay, this channel with the ESC. Okay, so you have PWM signal, and this has 3 pins, like, yeah, or you can tell 3 wires. One will be your, see this color, white color, red and yellow. Okay, 3 colors. A white color will give you the signal, PWM signal, which coming from the flight controller to the speed controller, and other 2 will give you the supply. Okay, 5 volt supply. So sometimes what happen, when you are connecting all the speed controller with the flight controller rail where you are connecting, okay, require the power. Okay, so mostly you have powered already. When you have power module, this will get powered, no doubt. This will get a powered because you have a power module, and power module will be connected with the flight controller. Okay, there will be on this. You can go with the circuit diagram. I will go through this one website where you will see this diagrams also. So power module will be connected here. Power module will be connected with the battery. Through the battery, this power the flight controller. Okay, but sometimes this is not going to power your this rail where your pins are there. Okay, so this has to be powered again. So powering this, you can use the speed controller which has inbuilt BEC. Okay, they have written the BEC, means inbuilt power. This will give you in power. Okay, I don't know, is it able to see or not? You can see BEC. Maybe reverse is coming. Just you can check. 5 volt.
UBEC.
Yeah, 5 volt at the rate 5 ampere. So that way you can get what is the maximum voltage this can supply to this rail. Otherwise you have external current sensor or voltage sensors to power this. So we use the voltage regulator. We have like a different voltage regulator. Maybe other day I will show you what are those components are there, and then you will in that case you can avoid this type of designs. Okay, because this is the very critical components. When you come up with this type of BEC inbuilt the ESC, then actually you're talking about the one of the diode. Okay, or maybe some filter. So if that get damaged, then whole ESC is not working. So spending 16,000 rupees and just because of one fault damaging. Okay, so you can avoid this, and you can use the current sensor or voltage sensor separately to power your flight controller rail. Okay, that is one thing. Now what is the next? I think I
So
saw.
that means the flight control always the powered, right?
Yeah, that will be powered through the power modules. That will be power whole system, not your rail. Getting it, right?
Yes,
And
sir,
your
yes.
signal will come from here only. So if your signal is not coming from here, then what is the use of this autopilot system? Okay, so maybe every function is working. This powering getting correct. All sensors are working. I will show you through this one GCS side, and then only output side is not coming. Okay, so for powering this, you need some ESC. Okay, yeah, speed controller or maybe current sensors connector connected with this, which can power this rail. Okay, then only you can get the signal, and this is the very good idea. Otherwise sometimes this damage the whole system. So many times what happen, a student will forget to remember you have to power the rail, and they will tell sir power output is not coming. Okay, so that should be remembering, means which autopilot system need to power the rail. And basics flight controller already like powered through the what is the internal power is available. Okay, so in that case is not required, but costly all autopilot system require external power source for the this one. Okay, like a rail itself. Now next one you've seen the servo, correct? This is a servo. Time being, I am not using the TXRX. Otherwise, you can control through this. So I think this is the 50 kg CM. Means at the end we are talking how much torque this can give. Okay, what the quality of this. So if a very high quality means this will be very good. Okay, that depends how much torque you are expecting based on your control rod, because at the end you are connecting the control surfaces through this control rod. Okay, so this will be rotating. Listen sound, correct? So this require 5 volt supply. You can use the same rail for doing that, or you can use the other any external source also. Okay, so when we are talking about the fixed wing, then we need minimum 4 to 5 servos like this. For every control surface you need this. Okay, but when we talk about the multi rotors, in place of the multi servo you need a motor. Okay, so that you have to remember. If there is no control using the servo, okay, in the multi rotors is actually is not required, only landing gear deflections require, so where they use the servo motor, or if you have a gimbal system then they use the servo motor. Otherwise they are not they are looking this type of systems. Okay, but actually fixed wing aircrafts, they have 4 control surfaces. If you have secondary control surfaces, then you need this type of servo. Okay, even with the costly, this also start with the 500 goes to 7,000 8,000 basics. Okay, otherwise this goes very costly, 45 50,000 something like that. That's the cost analysis how you mostly comes under the Unix system engineering. So I found propulsion system related, then I found the servo motor related. Now coming with the design, already explained one. I will show you just first this. Okay, hardware. Then I will. Okay, so just I will show you. I think basics hardware. You can check here. It will be good. So I've taken one autopilot system. Okay, I connected with the USB through PC. Okay, so this one flight controller, like you can go with the Pixhawk basics. They have given the rails. Okay, you can count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 channels are there. Hence maximum you can take 15 outputs from this, 14 outputs. Okay, and 2 reserved for the inputs. So what is this? There is called Ppm encoder. Okay, so when we talk about we want to connect with the receiver. Okay, so I will show you one receiver here. Mostly we are telling what the RC control, correct? So you will see like one transmitter like this. Maybe in exposure you are getting slowly all this, how is working that. Okay, so actually we are expecting the few channels. This is 16 channels. You have buttons, correct? Every switches are there. You will see multiple switches. So what is the idea in this? Basics 4 require. Okay, so basics 4 if require is check how this works. Okay, let's see this. So for a control system, any aircraft control, if we talk, then at least basics 4 controls require. You see 360 rotation, 360 rotation. But what is the option? If you leave this coming center, you leave coming center, leave coming center, but leave this is coming anywhere, very place. So what is the throttle?
It is for lift.
No, first listen that. This is the demand of the control. Okay. First you should know any TX when comes in the picture, coming with the one receiver like this. Okay, you have a receiver. This can work for 3 km, 1 km, depends 1 km, 3 km, 5 km range, but normally we recommend 3 km maximum. It's not to go more than that. Beyond of line of sight is not recommended. So if you're changing the antenna again, with the some more modems. Okay, if you have long range modems, then you will check, maybe you can improve the your range itself, means communication range. So this can communicate. If I am this place here both powered, then will work, no doubt will work. This will be connected with the flight controller. I will show you that. And this will be on the ground with the pilot. Okay, so pilot going to control the aircraft using this. Now when we use this, you have multiple channels in this. Again, there will be some input channels, some output channels. Okay, so just you need one output, and then you are connecting directly with the flight controller. So actually there will be different types of the connections required, and there is called Ppm encoder. Okay, if S bus is not there, S bus require only single, you can just go ahead with that. Okay, or same. But if you have something like S bus is not there, then it require at least 8 pins. Okay, so few receiver where you actually connecting the 8 connectors. Okay, and all are communicating through the single connections with the flight controller. Okay, so 8 outputs going with the single channels. You know that, correct? Multiplexer type of design, you know. Multiplexer comes with the controls. You have selectors. We are encoding all. Okay, and all the outputs which coming from the receiver side is actually fed to the flight controller for controlling the aircrafts. Okay, if you have this type of receiver, then this Ppm encoder is not required. You have just a single this type of connections. Okay, USB connector, and will be fitted in the RC in. Only just one need. Okay, that's the one thing. And then just I will show you the how this functioning. You need to power this, correct? I just powered, and details you can go through that, because you have complete autopilot system design. And for design you go with the PCB designs of the hardwares, and then you are developing the firmware for working this. Okay, so when you see this, multiple connectors are available. Every connectors has some important informations. I don't know is it able to see or not, otherwise from the documents you will see. Okay, so when you start with the like a receiver related connectors, then there is a buzzer. If any sensor fails, this will give you the voice, some command or audio signal you will get from this. Then there is serial port, then switch. This switch is important. Without pressing this switch, if you check that, if you press, then only this your system will get R. Okay, so this is the safety switch. It's not like it just powered and system is running. Okay, because these are very dangerous for the human or maybe anything. So if you're talking about the life, then very dangerous all these systems. Okay, because if you're not controlled, then propeller starts, then very tough to control that. Okay, so mostly we have safety for that. We should not press. If you press this, then this will be solid. Okay, once it's solid, then very carefully required to control this. By mistake, if this is the on, armed, then full throttle running. Okay, so motor start giving the full thrust. Okay, and if you're not holding the system, or maybe you are not like has taken any care there, means that will what is the threat, one like a type of threats for the life also. Okay, so very tough for controlling this type of systems. Okay, so what you will see, you have a buzzer, you have switch, then we are calling one GPS system. When you can connect these systems, then you have GPS receiver. So GPS receiver will be connected again with the autopilot systems, and idea is that you should have positions informations of the aircrafts. So where this system is available with GPS installed, you will see lat long altitude details coming with the GPS side itself. Okay, so that's the basics. I think you're learning again. Then I told there is a power models. You should connect the power models with this type of autopilot systems. And then other is also there. You have ADC, then you have another I2C connections, CAN bus, USB, SPI, So depends what type of sensors or maybe hardware interfacing with this electronics or autopilot system you're using that. Okay, so you should check what are the communication protocols are there. Okay, if camera also you can interface the camera. Okay, so this is the basics. We have a very advanced. I think you missed that, but it's fine. In the future, if you are coming, then you can get exposure, more details. Okay, so I will show you through the software side. So you should know basic software. Then you can explore from the website. That much today I will tell you. Then the next day I will try with the running something. Maybe I will try to run motor without propeller. Okay, because propeller becomes dangerous. So this system has all accelerometer sensor, gyro, magnetometer sensor. GPS also has a magnetometer and then GPS receiver that will give you the what is the accelerations of the aircrafts, then what is the PQR. You are knowing that, correct? With angular rate, and then you will get the heading of the aircrafts. Okay, so both system should be aligned such a bit that heading of the autopilot system and the heading of the GPS should be same. If oriented with the some angles, then you will see there is a error, or maybe your system is not getting R. Okay, so just see this basics one. First this I was telling what this. Okay, so if you give any command, this will take. Okay, because you have antenna. These are the antenna. Okay, and you have receiver model inside. So this is a complete receiver, you can tell, and this is the transmitter, remote control. Okay, so this is the antenna. Now if you're talking about this first channel, this used for throttle. So depends mode 1, mode 2. Some people are like a left sided, some people right sided. Okay, so depends what is the mode 1. If you mode 1, if you're talking, then we are talking about this side. Mode 2, then this side. Okay, so depends. Okay, which assigned the your throttle. So if you take, maybe we are talking about the channel 1. Okay, and elevator this, because we are going channel 2, this for roll. Okay, so this is aileron, and this we do the elevator because we can go forward, back, so using the elevator. And if you are talking about this, then you see this is the 100% throttle and this is the 0%. Okay, so this is called throttle inputs, and rudder will be again left right. So rudder and throttle will mix, and elevator aileron will be mix. Okay, so mostly depends how people are controlling this. And arming the aircraft, if in the software you have changed with the rudder arm, then either going to left or right. Okay, so mostly we do the inside down, like we do the right down. Okay, depends how you're controlling. You're assigning in the software side. DJ is also, they are doing the same way. So if rudder arm, other switches are there. Sometimes we do the, let's you are talking about the hover. Okay, so let's second channel assigned for hover, then maybe you're forward, correct? Yeah, stabilize mode, and one you RTL, return to launch. So we are doing the mode selection also for every channels. We are doing a selection of the different modes, flight modes, because we are flying, correct? Maybe all 0, we assign the all 0 possible, we can assign. So you have to assign through the software. Okay, maybe I will check with the battery and how to connect to this screen. I cannot connect now. No, I cannot connect to the screen. Otherwise I can show you how to make a model on this, then assign the channels, correct? So this channels, if you select like this, under the software also you will see. Okay, that is switching. Okay, I will try, I will set up one day, then I will check if working the software side also, then you will get exposure. So if you have, let's this the just like your stabilize mode. So when you start the craft, should put in the stabilize mode. Okay. Then once aircraft lifted, you're talking about the hover, then just change this by this hover and leave this like this. No need to control. Okay, for given throttle 50%, 60%, just you stabilize to hover, keep like that. Aircraft supposed to be hover. Okay, because that you can keep the TX anywhere. That is the like autonomous how is working. And when you are let's say getting miss the aircraft, okay, and you want to get return back, okay, so in that case just you have to apply the RTL. If you apply the RTL, there is a chances this signal will get received by the aircrafts, okay, then you will see like your aircraft returning back to the return to launch system, location, okay. So where you are launched from there, again aircraft is coming back, okay. Similarly, you have another assignments like you go with the multiple hovers or maybe going with forward, back. You can stabilize different modes, okay. So is there this all assigned through this during the software, okay. So this is the basics, I think. This is the RC control. Now I will take you one just a diagram. I think I just have to check. Are you able to see the hardware?
Yes, sir.
What about the screen?
Screen is not.
The screen is not visible. Just 1 minute. I will use my tablet also. Both are visible, screen as well as video. Just I will show you, then I will be taking through this one. It is not coming. What is the visible now?
Yes.
What is it coming on the screen?
MTech event first semester.
Huh?
First semester building files.
Yes, I just have to change this. You getting this one?
R2 pilots.
First, I will show you the one hardware, this one, motion. Then you will check the behavior of that. Then I will go through this. Will off the video that time. We'll do this one. Okay, so timing what we are doing already setup is there. Okay, we have done the setup. I think I explained all the setups, and mostly already code is also flashed here. But I will tell you mostly how people flash the codes. So this is like a GCS, open source GCS mission planner. You can install in your system also. Download this, and for that you have to go through the one autopilot.org. Okay. Are you able to see this autopilot?
Yes, sir.
So you are going to open this. In this website, you will get the doc file. Okay, you can read from the doc file also. Details you can go through this website. Lots of details are there. You can read that. Going with the particular aircrafts. Start with one of the aircrafts, either fixed wing. If you're going with the fixed wing, then single propulsion system and multiple servo for control surfaces. Okay, that you have to make sure that. And when you're going with the copter or maybe multi rotors or something like that, or maybe what is called VTOLs, then you're going with the multiple motors. And if you VTOL, then you have multiple servo also. Okay, so it depends how many channels, output channels require. In that case, you use the main output channels. If main output channels all used, then you go with the auxiliary channels. You have to assign internally. Okay. Otherwise, there is a limitation. Maximum 8 channels will be available as a main channels. Okay. So I think this is the details where you are going to read. Okay. Today you can read, come up with the some what is called reports. Okay. Then if you go with that finally, then they will go with the mission planner. APM is also there, mission planner also there. So you will get this software. The software side, if you want, you can download that. I think somewhere, if you go with the download, somewhere will be there. With that, maybe Windows installing that, you will get. Okay, so you can download. If you have Windows related the PC, then you download this. Okay, this software you can download. Once you download this, I think these are the process you can follow. Okay, simple process to download. Once you download, open this, you will get this software. QGS ground is also there. Like you can go with that Q ground also. Okay, Q ground controller station. So Q ground is also, but that is a different types. You can check it. So normal layout comes like this. You have one PFD. Okay, primary flight display. If you want to increase, you can go with the swap with this one, or similar MATLAB side also how you do to undock that. So you can undock completely, or maybe you can have here only. Okay, so standard like you can keep here. So where you want you can do. Okay, so if your GPS is active, then you will see your map will be here. Okay, and if GPS is not there, then you will see the what is there. Okay, reflecting now. So GPS should be active once you connected this. So we'll get complete map like this. So if preloaded, then you will be getting here. If GPS connected, then you will get getting here. Okay. So what is type of map you are calling? You go with this. Okay. Here will give you the satellites. How many satellites are there? And this will give you the dilution of precision, horizontal dilution precision, or vertical dilution of precision. This is very important term in the satellite theory. Based on the DOP, you will get the improvement of the satellites. Okay, means what the accuracy of the satellites comes depends on the DOP. So this will actually DOP connected with the volume made by the satellites with the receiver. Okay, this will be universally proportional to the volume made by the 4 satellites, including the receivers. Okay, so if your satellites are distributed different directions or maybe different area in the space, then I think will be very large volume, and your DOP will improve. So if 1 to 2 mostly DOP will be there, and this will show a number of satellites. Based on that, you can check what the accuracy of your there. So 10 to 12 satellites supposed to be detected every time during your flight. Okay. So what are there? If you click this, I think just I will show you. Just I have taken out completely. This much items or maybe parameters you can display on the screen. This is very huge, correct? It's very huge. So if you select particular this one, you have to open this, go with the all type of data, airspeed, accelerations, altitude, angle of attack, temperature, voltage, current, outputs related to the servos. All details are here. Your heading, what is called magnetometer sensors related details. All sensors details you can call in the your PFD side. Okay, but will becomes very complex to observe the your this one information. So we expect what are the basics information required. Those information you can click. Okay, so let's say this you want to get settled down there. Cut this. This will be here. You can make large. Okay, I will be taking out that after connections. Okay, so let's see how this. These are basics informations. Telemetry logs will be here. What are the actions you are expecting? I will be explaining this. First, I will show you this. Okay. So there is a two connections now connected with the USB, this USB with the monitor. Okay. So your autopilot system connected. Are you able to see the video? Huh?
Yes, sir. Yes, sir.
Okay. So this is connected with the, your laptop, the USB through the USB. And that is the power source, and this power source as well as the data transfer, both purpose this used. Okay, so how you are going to connect? If you are calling this, see some COM port, you can go with the control, yeah, device manager. You know that, correct? How to search the port? You know that? Yeah, I will show you. You have to go to the device manager. And you will see here ports. If you click the ports, then one flight controller connected, flight management unit. Okay, this is like one of the control system, the autopilot system connected with this hardware, a PC. Okay, and this will show you port settings. Now baud rate given 9600 and data bits 8. Okay, and port number if you go, I think just general driver, COM port 4. You can go with the advance and check communication port 4 used for this. Okay, another port already in. See how many ports are there. USB ports, 256 USB ports you can connect. So this is a communication port. Okay, now communication port 4 detected, and time being the 9600 baud rate is there. So for autopilot system, you have only two options. If you are connecting through the USB, this is like a fast data rate transmission. Okay, you should go with the 115,200, 1,15,200 baud rate. Okay, when you are connecting USB, physical connection. This is not available when your aircraft flying. Okay, all are wireless that time. So that time using the telemetry like this. Okay, so you should have two telemetry, one connected with the flight control systems. Okay, and other will be, this will be connected with your what is called PC, ground controller station. So this will be transmitting signal to this, and through the physical connections will be passing to the flight control. Okay, And again, flight control informations again transmitting through this and receiving with this and transmitting to the your GCS side. Okay, so this is like a transceiver, means you have transmitter as well as receiver both side, and this is working at a particular frequency. So depends what type of like your telemetry you have. This is like 915, and you have one RFD 900, like similar type of this, where you are using the other type of very large long range type of. And if you're using the Yagi antenna, those type of you can achieve 40 kilometer 50 kilometer range like this. Okay, so it depends how. This is the cables, this will connect with the GCS. Okay, so again this is the USB, this is a ground station. And maybe one more models require, but that should be very small, and it is not there. Okay, what a small similar model will be there, but this will be very small. Okay, or you can use the same type of antenna. So this is actually antenna, this part is the antenna. Which antenna is there? Now you learn, correct? You design the antenna. This is the dipole antenna. Okay, this is a dipole. A dipole fitted to the end of this, not a mid. Okay, or maybe internally connected somewhere, because copper wire will be inside. Okay, this is the black color is actually what is called this will give the strength of that, but internally there is a cable, that is the copper wire. Okay, so this is the dipole antenna. You have two antenna, you can go with the 90-degree phase. Okay, for achieving good pattern. Okay, so that depends how you are arranging the antennas. Okay, or you can go with the Yagi antenna, go with the patch antenna, depends. Yeah, go with the helical antenna. So what type of antenna you are expecting for achieving long range, based on that you can decide. And sometimes I don't know you have seen or not, but in their top side we use the flexible type of antenna, means not a physical like this. Physical will be there, but not hard like this. Okay, that will be like foldable type, so you can paste that antenna on the screen. Okay, so any aircrafts what the surface is there, you can just paste. Okay, and you can use for the communication purpose. So this is very long range, uh, getting 15 kilometer or maybe 40 kilometers, something like that. So let's say you should have this exposure little bit. Now, so we are connecting 1,15,200 baud rate COM port. We will try to connect this. Let's see if there is no problem, this will get connected. Should not happen this much. I think we are taking time. There is an error. We'll off it. Just try once. Now see, signals came. This is giving all types of the color signals. You can see that blinking, that this will become solid.
Yes, sir.
So now previous this was detected communication ports 4, correct? Now detected 6. You can check with the device manager again if you want, but already you know that already I saw to you. Now this is the communication port 6. Okay, you can open this, you can check what the baud rate. Okay, now you set this. Okay, and then connect once. So all the sensors they will detect, they will be checking once. If everything is fine, then this will be get connected. Otherwise this will show you. GPS detected now. I think 9 satellites detecting here. Just see. 9 satellites, and dilution of precision is actually 2.2. So it's not good. Okay. This should be improved. But fine, I think this is the more than 4 satellites. That is the basic requirement. But we expect at least we should have 10 to 12 satellites. But I am sitting in the chamber, so because that maybe number of satellite is less, and after 6 p.m. or maybe 6:30 or 7 p.m. you will see the problems coming. Okay, so you should improve the dock based on the number of satellites availability. Now this detected. Okay. So you can check your UAV is where, which locations. Now, what is the meaning of this? You see the department name, correct? Are you able to see the campus?
Department I can see, sir.
Yeah. So I think where I'm sitting, you know that, correct? Now you identify. I think
Yes, sir.
beside your lab, beside your department, one more lab is coming. Let's see. So you're flying the UAV. This will give you like a live. But what is the problem? Can you tell me now? I'm sitting here without the aircraft. What aircraft is running, correct?
Sir, it's moving.
Moving, correct? So this is the error. Okay. If you keep your receiver one location, this is not accurate. Means around 300 feet or 350 feet range, this receiver will be get located. So you should check, okay, at least there is error 300 feet or 400 feet, always error will be there. So this indicates the same. Actually, our GPS receiver kept one location in the chamber. Chamber is fine, that is indicating where we are here. Okay, so that is fine. Internally they are showing, but they are locating, they're crossing this. Okay, you see, I think it's crossing the building itself. So that is not a correct idea. This side a cafeteria, correct? This side a cafeteria. You know, this side a cafeteria. Okay, and this side director office. This side, correct? Going this side. Okay, so you can go with the student plaza where you want now. I will show you through this point also how mostly you can select that. Okay, so this is the idea, like how aircraft you can detect on the GCS side. So if your GPS is working, then you place hold the system on the aircraft. If aircraft is flying, you will get the complete details. Where is your aircraft now? Okay, so mostly we fly when 5 kilometer or more than that, or 10 kilometers. Then it is crossing actually seaside, going seaside. Okay, so we'll cross sometimes Malpe, sometimes like this beaches. Okay, I'll show you. Okay, so just now this is the showing your this one GPS related informations. That is one thing. Now next point is here, correct? All the sensor related information is coming. Now showing the gyro is not good. This arm, okay. You can arm from here, but everything should be pulled. Okay, this is the Kalman filter. GPS is on. This is 3D fix. It's fine. GPS is very good now. Time being, because that's coming. Quality is also good. Okay, now just I'm orienting. I placed on the plane. So you see, what is this?
Sir, equal line.
Zero pitch,
Altitude.
correct?
Sir.
Yeah. So this suggests a zero pitch. Now I'm going up or down. Tell me.
You're going up, sir.
So is it pitching up, pitching down?
Pitching up, sir.
Pitching up. So what I'm doing, just see the autopilot system. I've done up, but there is an incline now because my hand may be inclined little. So actually, what we are talking, we are going. Your aircraft is going up, nose up. When going down, that's aircraft down. That's that. This negative pitch, correct?
Yes, sir.
But when going right turn, I am talking about right turn now. Right turn will be opposite of U, correct? So
Yes.
see, I'm doing right turn. What are the screen says? Left turn.
Left turn, sir.
You know this one, correct? Relative motion. You take any buses, when buses goes forward, then all the screen come back, correct? That are relative motions. This is same way pilot should get a feel if left turn means they should take the right turn. So this is actually right turn, okay? And what this angle suggests, this means 30 degree. Now this is 30 degree angles. Right 30 degree. And with the pitch also. Pitch now is the actually nearby some 10 degree.
Yes, sir.
Okay, that you can check 10 degrees matching. So this line, what is the line is matching with this? This is the horizontal line of their aircraft, like a being related, and this will tell you your what is called altitude, this side airspeed, vertical speed. If you're going like this, then you will see the speeds. Okay, now I'm taking left turn. This is left turn. So see 30 degree again. So I'm going with the 0 degree now. 0 degree. Okay, so this is like a origin line, a line. Some error is there because of my hand, nothing else. Okay, so this is your PFD. What is this one? Any idea is there? What is this is suggesting? Top? Can you tell me? Now see.
Attitude, sir.
What is this?
Sir, the regions, like
How you
directions, sir.
remember?
Directions, sir.
This heading. This is the heading.
Yes, sir.
Now I am going north direction. This may be north around 259.
Not one degree.
Let's I cannot hold my hand like this, but this is 0 degree, 359, maybe 0 degree. And now just I'm telling, I'm going with the north directions. Can you remember? Let's see.
Not 341. 357.
Okay, so depends on this. You will see the aircraft orientation here, correct? Okay, and when you are moving, then you will see how your aircraft is changing. Just see orientation you're changing, correct?
Yes,
Are you
sir.
getting? So let's say your aircraft is not visible and you started forward like this, forward, but suddenly you got like a beyond line of sight, you're not able to see. How you will know this aircraft is going forward or coming back? Because your control get reverse. If you change this, okay, then your control will be the same. When you're applying the same, it's actually returning back. Okay, so pilot, they should know when they are going forward, and if same direction is going, what is the orientation of this? And if I am taking back, this means all control is reverse. I'm taking 180-degree turn now. Just see that heading.
Yes,
South.
sir.
South. Got it, correct?
Yes, sir. 140, 150
Maybe
degrees.
some error is there. It's fine. That is fine. I think maybe south is coming like this. What I should be. Little bit north. Okay. So this one turn means this also turning. This also turning, correct? So without looking the physical aircraft in the air, you see the your GCS, okay? And by looking GCS, you can control the aircraft. Go with forward, back. That way, mostly we are learning the how to fly the aircrafts. Okay. I think this much just idea was there. And next, I'm not sure is it telemetry is connecting or not. I will disconnect.
Sir, but it tolerated is much distance from
Which distance?
means the aircraft is the guy. The GPS is in the room itself, but the aircraft is showing like tolerated with the region.
This one.
Yes, sir. Right. Sir. The
I'm
picture
sitting
GPS.
here. Eh? Your
Sir.
aircraft is not flying. Just your
Yes, sir.
autopilot system kept on the table.
Yes, sir.
So of course there should be no speed, no altitude change. What are the change is coming? Actually, that is the problem because of the GPS. If you have very good quality of a GPS, 10 lakhs around GPS receiver cost, then your improvement like precision will be good. Other 5,000 or 10,000 GPS is not a good. Okay, it should have very high quality of that. You see 300 feet, how you will predict? You will cross 3 buildings. If in the city, then I don't know how many buildings you will cross. You're getting correct? See, this is just a screen. This cross, I think this cross around 500 meter now. If you check, just a rotation.
Nearly, sir. Nearly 500.
This is showing around KMC volleyball, Marina.
Yes, sir.
The temple, correct? You're getting across the temple. This is the management school. This is getting around Marina. Where is the Marina? I know you remember maybe. And this coming around actually placed here, but little movement if there, then this is going very fast. Okay, but in the actual when you will in the air, then is not this much error is there, because just testing on the ground switch coming like that. Once position fixed, then this perfectly will work. 200 300 feet is fine.
But we can get with the camera, sir.
Camera will be there. You can run the camera also. I think maybe webcam I'm using now, so this is not working. Otherwise, on the screen you will see the details, camera details also. Is there, possibility is there. But if your system is not guided by the visual navigation, then you cannot tell camera going to use for navigation purpose. That is the different theory, visual navigation guidance. This like you are using the telemetry data, lat long, altitude, and then I'm showing that also little bit. Where is the GPS? I think I got a cut or what? So today task, 2 days task I have given to you. Monday I will show you more setup related working little bit. This is the complete one main board. What is it called? Main electronic systems of the aircraft is on to you. The rest is like plug and play type of equipments. If you want extra accessories, you can do that. But this is the main boards. So if you have completed this setup on the single board, means you're actually working with the complete autonomous system. Most of the hardware is this much is enough for the autonomous system. So I think it's fine now. I will show you just functions. I will off my video. I'll show you these functions a little bit. Okay. Anything you want to see the hardware? More? Next class I will show you.
Sir, can you send me those pictures? I just go through the internet and search on it.
Okay. Just 1 minute. Where I kept this one. Yeah, so just I kept basics hardware. I will give you one photo. I don't know how to take. I think I sent one image. Can you check?
Sir, two images are editing mode.
What?
They are coming.
I mean, just sending the one small videos. Okay. So anything you want to check from this?
No, sir.
Okay, so just I will off my video. Yeah, check the screen now. This is the important to learn. So maybe Saturday I will be telling to you to explore more. Okay. Monday I will be coming then. Huh? Is fine? Okay.
Okay, sir.
Now just I'm going telemetry side. What you will see, if you have already logged file, a recorded file, you can play with that also. or you can load the log file, previous file if there. So for analysis part, we are doing that also. If you want to record, you can record that. Like there was options, you can record the camera, you can record from here also. Record the HUD to AVI. Means what is this? You can, if you want to record, this will becomes the video. Okay. So what you will do with this hardware now will get recorded in terms of the video. Now, quick side, if you check, first telemetry is on, correct? Telemetry, then go with the quick. I think now you are looking what is the altitude, ground speed, you can check from here itself. So time being like 1.57, what is called heading coming. It's sort of matching with the here. Okay. It's like a heading. Distance to MAV. Okay. So let's you place somewhere. Initially you place somewhere in the field, and now you are placing our system here. So this will tell you from the your initial positions to here. Now they are telling like around 1.5 kilometer ahead.
Means how much distance it passes.
Yeah. So if you start initial, then you should initialize that. Okay. So your that particular locations, your RTL locations will get initialized. Then only you start running your aircraft. Otherwise, they will consider the previous one. So what do we do when we fly? Then we first initialize this one locations, and that will get the initial point. Okay, so your aircraft will be the same as a physical on the software side also. So software side and your physical aircraft locations will be the same. Otherwise, this is showing like 1.5 kilometer around. Vertical speed timing, this is already stable, kept on the table. So of course this will be 0. Your altitude is also 0 timing. If you have waypoints, then you can go with the different waypoints. I will show you how you are creating waypoints on the mission planner side. This is a mission planner. Okay, so you can create the waypoints. I will show you how to do that. So this is actually your home. First home initialize here. Now if you UAV side, I think this is the your. Actually UAV is changing every time. So where is the your home? You have to assign first where the home. I think just I have to check our locations. I have to go with slowly. Manipal Park. Where is our this one? Where the MIT? We'll see from here.
Is there, sir?
Next point, I think not required. If you want instrument related, then you can show that also. The status of that means what are the parameter related status you can check. Servo related you can set. So this is like how you can set the servo commands, minimum to maximum. And I don't think any pre-flight action. Yeah, this is the important. Okay. So what do you want to do? Loiter mode, return to launch. So these are the flight behavior. Okay, if you want, let's your aircraft flying at that particular altitude, same locations, then you put the loiter mode. If you want to, let's your aircraft should return back when there is a loss, line of sight, or maybe if there is a telemetry loss, something there. Okay, maybe RC is not coming in the your signal is not available, then you can go with the return to launch. Okay, so these are like options available. You can perform that. If you click that, then that will do. Okay, this is the auto mode, but you can go with the stabilize, altitude hold, acrobatic, auto, guided, loiter mode, RTL mode, return to launch, circle, landing. Okay, so these are different flight mode. Which one you will apply here? Based on that will be performed. So if you select the stabilize mode, set mode, You will get the stabilize here, correct? Already stabilized, and there is called arm disarm. So if every sensor are working, then only you will get arm. Okay. Other you have to disable the all sensors, then you can do the arm. But you should not disable the sensors because all sensors required during the flight. Okay. So if you arm, then there will be arm here, and you can disarm when you do that. So time being sensors already has issues, so giving the disarm problem. Okay, fail safe conditions is there. Gyro problem is there. Okay, they're saying that. If you go with the RTL also, you can go with the RTL. So see the RTL is coming here. Okay, if switch from the RC also, you will get here stabilize RTL. What you will switch, that will come. If you want loiter, loiter will come. If you want auto, auto will come. Okay, so RTL, loiter, auto, or you can fix from here also. It's not like always do from there. Set a mode. Yes. Now landing, you said landing is coming. Getting correct? So that way mostly we do that, like how to configure the your RC control. GPS coming going now. Okay. So you can check all the instrument informations. Lots of informations are there. Which information you want, you can just click that. You will get on there. Let's I'm selecting the air speed, and let's battery related. We will see the battery related, battery voltage or something. Battery not connected, so I don't want now. Let's what we can do one more, because battery is not there. Let's battery. At least we will see nothing is coming out. Correct. Battery temperature. Take the air speed first, and battery temperature. Okay. So doing this. Just see air speed highlighted, battery temperature 0, because you have not connected any battery with this. Okay, so depends how you connected the instruments and how you selecting that will come. Okay, this is the importance there. Now I think yeah, so this much there. So fast I will go. And if you want telemetry also, you have to disconnect this. I will show you. Maybe it's not connecting now, but I will go fast. If you want like you want what is called mission planner, like you want mission. Okay, so you want to follow the particular waypoints. So where the UAV, this is the your home. Maybe home would be somewhere you keep that first, because this should be in the MIT, because we kept in the MIT now. So where is this now? I'm getting forget to where the locations. Let's don't worry. I think one location is already specified here, and that location can be anywhere. Correct. This point. I'm not sure where is now, but this suggests maybe at the highway somewhere we kept first point. Okay, and then you go with the another points, so you can select the waypoints. Correct. So this is the first point created. First point. What is the waypoint you want? Takeoff or landing? Okay, is it takeoff? Let's get takeoff from here. So actually this is the you should bring here. Correct. Should bring here. The next point, third point, fourth point, fifth point, sixth point. How you will do? Like I want our UAV should follow this. So you are designing the waypoints and then returning back. Let's like that. Okay. So I think captured this. This captured around 2.1694 kilometer. If you check all distance, this captured. So you have to assign every point. Let's home takeoff. You should assign this is the takeoff. So starting with the takeoff. Okay, starting with the takeoff, and then going with the second point. Second point, what you want? Let's second point should be around flying at particular height. So what do you do? Go with the stabilize mode is there. Waypoints, go with the waypoints, no problem. Go with the waypoints, and let's you have change this, already changed, correct? This changes. Okay, and altitude you want, you can change the altitude. You want 200 meter, you go with the 200 height. Okay, so that way we are changing, everywhere we are changing. Okay, you can change that. So every point you have to assign what are the waypoints you are looking. Somewhere you are going with the takeoff, somewhere maybe you are going with the forward, then we are going with the hover, somewhere coming back again forward waypoints. If you are not doing any mode, just put the waypoints. Again coming here, you want to hover, do the hover, and then returning back, give a landing again. Okay, like altitude 24. So 17, after that you're actually coming back to the return to home. Okay, so this is the waypoint how mostly people get created. You have multiple this screens, maps. So which maps you want, you just have to check. I think already I selected, so depends which this, what are the maps available in your case, or maybe in India, that will be highlighting here. So being a hybrid, different country has a different maps, you can go with that. Some maps has updated, some map old, so depends which map you are looking. Google map, you go with the Google map. Okay, so all are there. If you're looking maybe any other hybrid, Google satellites map, you go with the Google satellites map. So lots of maps are there, and let's say you're flying, but particular area don't have net connections. Net is not there. How you will upload this? So you should download this before reaching to the hilly area where maybe internet connection is not available. You should download the map. Then only you can pre-plan. Okay, otherwise you can't do that. This is a terrain map. There are the one options, initial setup. I think this is installed. You cannot do now because already connected. These are mandatory hardwares. You can go with the frame types if you are looking multi rotors or particular this. You have to select that. Is it the plus or by H configurations? Which configuration you have to select in this also. Then what is called accelerometer sensor calibrations. You are performing through this. Compass related from this. Okay. So when you are doing the new one, then you have to do this. Okay, and if your joystick or maybe RC connected with the flight controller, then you will see the data here. Okay, this will be active. Time being your RC is not connected with this, so you are seeing 0, nothing is there. So servo output you can check also how many servo you can connect. That also possible. You can check running the motors. You can run directly through this. Okay, and then ESC calibrations. Mostly comes with calibrated. If not calibrated, then you can calibrate. Okay, flight mode. If we're switching, I think I switched the stabilize now. I switch the, maybe you can switch. So if your control comes with the, if a stick comes with the particular, you can just select and switch which mode you want. You save that. Okay, so I already is on the stick, correct, in the transmitter side. Which flight mode you want, you can change that. If this is the stabilized, you can put the altitude hold. This can be a loiter modes. Okay, where is the loiter in this? Yeah, this one you can keep as a RTL. So depends which flight mode you are looking there. That way you can save. So there fail safe also you can do, because sometimes propeller if they are and starter, so you make fail safe hardware details. Additional hardware if you want, you can explore from here. Lots of hardware integrations there, and configurations related. If you want full parameters, how to edit that, we'll get from here. Okay, if a radar arms you want, yeah, sensors arming check one means all sensors should be active working. Arming radar 2, if you select radar 2, suggest arm or disarm by the radar. Okay, that is the meaning. So actually what is the need, based on that you are learning this. So lots of files are there where they explain everything. If you want, you can spend time to read this, and if you want to change anything, let's say I want to change just the sensors, that should work. There are the arming check. Yeah, let's this army check 1. arming only. Let's this just click the 1 and I want to write this. So write parameter, okay, then okay. So this will get 1 chain. If you want 2, then you have to again click that, write parameter, okay, okay. You can search from here also. You want arming and go with the arming, you can check with here, okay? So they will highlight arming, okay. Arming only will come, arming related. So you can search from here also. You can select which sensor should work. So this is the configuration parameter where you are changing all, and then simulations is just rest other basic features are there, but these are the very important. Okay, they're very important. Only just I will show you one. I am not flashing the code. Only if you have hardware, then you can flash. So now disconnecting flight controller. Just 1 minute. So I have taken 3 experiment. You can make a multiple. So you have to disconnect this. I think getting hang now. You're not on that one, that website, ardopilot.org.
Noted, sir. Noted, sir.
Maybe some problem is there. I thought I will show you how to. So MATLAB side you finish all. I think I explained the all 5-6 experiments.
Sir,
And,
in the last semester lab team, I have seen the links of videos. I was following that, sir.
oh,
But
so you
the
can
thing is, my sir.
No, you was asking something, yeah.
Sir, but my MATLAB is very slow, sir. It was very slowly responding, sir. So that's taking so much time.
What about your laptop is good or MATLAB is not good?
MATLAB is good, sir, but my laptop is very slow.
Now, what do? You installed less packages and check your all task. If multiple tasks is running like a back of the PC, then maybe
Yes, sir.
so all thread, yeah, what are the other tasks is running, you can stop that. I'm facing the same problem. Now
Yes.
MATLAB is open because that I'm getting problem.
Yes, sir.
I am taking class from the other PC actually, especially Simulink side text. Now disconnected. Okay, I think this is last. Just I have to tell you, if disconnected, a flight controller already connected. Okay, with the PC, then only you can flash the code. So when you want to flash the code, where you should go? Initial setup. Okay, is first you should flash connect your controller through the USB to PC. Okay, and then you are just going with the initial setup, and if you click the install firmware, then I think this will be highlighting. Okay, so I'm not flashing now because already code flash sometimes it gets problem. So this will start flashing if you click particular, like you want to click this fixed wing, this hexacopter, you click that particular, this will start uploading the data. Okay, so they will guide you. This software itself will guide you. Disconnect without clicking, then click first, then connect again. Once it finish, then you will see like a software uploaded in the hardware. Then you can check further for calibrating this hardware. I think not connected, so it's showing that. Okay. Now last one point, if you have telemetry, I will check if telemetry is working or not. So I will take telemetry. You have seen the telemetry, correct? This time connecting telemetry with the PC. I hope if get connected. So time being the system, your autopilot system is not connected. I will check. I think COM7 came. We'll see once what is that, and maybe I have to go with the 57600 for this one telemetry side, because this is not physical connection. This is the wireless RF side. So I will check. If get connected, then data transmission will be there. Otherwise, it's not there. Okay. I think same issue is coming. I will power off once, then we'll check.
Every equipment has a different coding, right? So for that.
Yeah.
Correct.
Which one?
Codes are in the top column.
Communication side.
Yes, sir.
Yeah, that will be there. And every things has a different function, but some common communication protocols they are following that, and in this they have followed the MAV protocols. So just I have to check because 2 port is detecting. So we'll check which port is actually getting the telemetry. I have to try both port. One of the ports should get connected because one port connecting with the USB. Now this port is got the error something. Okay, let's what connected. Why is this problem is there? Yet coming working. No, it's so disconnected. Oh, is it? Oh my God. I started running that. So there's no memory available now. Where is that file got missing? You got the idea? What happened? I started recording the session.
Yes, sir.
This is session, and I think recording in the our C drive. So got a field completely C because that is not working now. I have to delete this. Oh, I have to check latest. Okay, so that's the way. I think this data is not there because that problem is coming now. Where is this supposed to work? Which one I have to remove now? I'm taking a little bit late because of some reason. So at least you can start learning and making reports. Okay. Finish fast. 5, 6 experiment if you can do.
Yes, sir.
Okay. Monday then I will show you this one. I think why this problem came. I don't have a space now. Somehow this get filled because of recording.
Okay, sir.
Not 0 bytes.
Very consumption.
Started recording that very that failed completely. No check. Okay. Yeah.
You can use this OBS software, sir. This may help you.
We'll check, but I was not sure now. This will fill the all.
Yes, yes. Sir, can you share us this Eagle tutorials for sir? I mean,
Eagle
for the
tutorial.
examples.
Which tutorial?
Eagle, sir, Eagle.
I shared na.
You shared two only, sir, but not the all the experiments. Only LPF is there and Arduino example is there. But to learn
No.
more,
In the Eagle itself, you have all the designs.
yes, sir, it's showing the just like boarding itself is showing, but the procedure and for the to design it is not showing PDFs.
No, for this Arduino, I share one PDF
Yes, sir.
during the exam.
Yes, sir.
So steps was not there. Huh?
In the Arduino is there, sir, but to learn more, there is no document for the for further experiments, sir.
Okay, I will check. Then I will share one or two. If you know one or two design, I think that is the enough to explore more. Only simulation left. PSPice model, nothing else. How to code that? How to call the this one PSPice model for that? Okay, because simulation is also important. What you learn designing, you have to simulate also. After
Yes, sir.
simulation, you will see that. I think system view software you have seen, correct? Where they use the similar type of designs libraries, but they are simulating also. So same thing is here also. Only problem is their pack depends on the package. If you have not downloaded the complete package, then will be tough to map the every components with the simulation related modules.
That is it.
I think I will check and then we'll say lots of learning is there now. Your RF starting 19 July.
Okay, sir.
You
Sir,
seen that?
yes, sir. I just seen that VNA and RF. I just seen that.
Okay.
Sir, in the MATLAB, I just completed one experiment completely, but in that I just prepared one report in the class. But in that it's showing like some of the errors. But in the plottings, it's showing same for the both.
No, if error comes, then how we will get the graph?
I don't know, sir. But
In the
for this,
simulink is coming. Maybe the minor error will be there. That is not your result specific. Maybe internal some error will be there.
okay, sir.
Otherwise, if error is there, then graph should not get there.
Yes, sir. Yes, sir.
I given the complete this one software also. You just try once. You
Which
can
one, sir?
practice. You can practice and then you can change the data. Try to learn that.
For which one, sir?
Related to the this one, 6D off. I share in that link, not this one. This time especially for missing experiment I'm taking now. And 5, 6 experiment already done with those juniors.
Okay, sir.
Because juniors lab is advanced.
Yes, sir.
Okay. So they are taking all those labs ahead of the semesters to get more exposure in the future. So till 6th semester, they should be looking like a final MTech type of labs
Yes, sir.
because that we have planned for them. And because you are starting first, so we have to start with the starting phase, then ending with the advance till 2nd semester. We don't have a 3rd semester and 4th semester now, so there is a constant. Either going with the less theory and less practicals. But options is there. I think PCB hardware is also coming tomorrow.
Okay, sir.
Once you come here for a presentation or something, maybe visiting, or maybe if people are here, then you can request so you can visit to the.
So in that circular they told for physical learning you can come to Manipal again. You can explore here.
But you tell only once. I will be suffer in that case because that I, I am active because of that. You should not make too much suffer to me.
Okay, sir.
You can come, no problem. If you want, like let's all people they should you they take time because at the end I supposed to be there, correct?
Yes, sir.
Two more faculty is coming now. I think one is there, another is coming. So maybe I will hand over to her. But option is there. If you want a physical experiment, you can come. You can use the hardwares. Software is also there. I given the access of the software. At least hardware you can use and you can do that. recording already is there. You can follow.
Sir, just asked again, Alka madam. She told I'll check once and will let you know. She told, but I got a mail from the VTOL, sir. They rejected the resume.
Which company?
VTOL, sir. VTOL.
She called.
VTOL, sir.
Dipole Aviation, Mumbai, correct?
Yes, sir.
I think government agency also calling to the students now. One of student from the UGC got a call from the government now. I share the details with the some synopsis projects.
Yes, sir. I just submitted.
She got a call. Maybe they will check.
Okay, sir.
First for 3 months they are calling minimum 3 months. Update. What is your this one? If you are looking the audio those things, then I think it's good, not a bad. Parallel, I have sent a few company L&T I send, but I have not get replied. Only team leader reply I got. HR reply I did not get.
Personally, I just went to this some of the startups like Dhruva Space, like Earth to Orbit, likewise.
Idea 4G you check idea 4G.
Idea 4G, sir.
Yeah, idea 4G.
Okay, sir. I just sent that back-to-back mails to them, and just if there are any contact details for the call, I just called them and told regarding this. I just said
It's fine. I think after this semester, we will get them. I'm not sending other student to dynamic because those people are facing the problem. Otherwise, I supposed to call to vice president. Previous time they have taken 5 students. VTOL now because the stipend one Utsava is not taken. So because that we are missing. Otherwise 6-7 students supposed to be there as an intern.
Ayush got there and Utsav got rejected, sir. Utsav selected but rejected.
Who?
Utsav, sir, we talk.
Utsav got shortlisted, but he told stipend is not as per.
Yes, sir. Yes, sir. These are Puneet and Chetna, Deepak got some other company.
Yeah, they are going to Hyderabad.
Yes, sir.
Deepak, Puneet, Chetna, Akshita.
Yes, sir.
And I think Monica, she told she's interested in the HL.
Sir, she told, sir, she trying in the HAL. She told me that.
And who asked for a DRD?
I just called.
You called. Okay, sorry. Lots of pressure is there.
Yes, I can understand.
I think recording is going on. I will stop that. Just 1 minute.